Dear students, let us go for the study of nomenclature of the coordination compounds. Once we know the coordination compound, the next target is to know how to name the coordination compound. That is named by using certain rules. What are the rules to be followed while naming the compounds is the study in the nomenclature of the coordination compounds. While naming the coordination compound, we have to name the cation first, then the anion. Which is the cation? The ion or the complex which is written first is the cation. See in the example potassium ferrocyanide, potassium is written first. That is why potassium is the cation and the entire complex is anion. Another example, tetramina copper sulfate complex you can see. Here, complex is written first, sulfate is next. That's why entire complex is the cation and sulfate is the anion. In one word, we try to remember which is written first, that is cation, which is written next, that is anion. I repeat, in the example, you can observe potassium is first, that's why potassium is cation. In second example, complex is first, that's why complex is cation. Hence, which is written first, that is cation, and which is written next, that is anion. And that cation is named first and then anion. Okay, once we know the cation first, then anion, then we have to know how to name the complex. Inside the complex, we know that a central metal atom surrounded by a definite number of ligands. While naming the complex, otherwise which is written inside the square bracket, while naming the complex, we have to name ligands first, then central metal atom. We have to name ligands first, then central metal atom. If only one type of ligands are present, then it is named directly. If suppose there are more than two different types of ligands are present, more than two different types of ligands are present, then the ligands are arranged according to alphabetical order. According to alphabetical order. Here you can see one is amine, AMMINE, amine. Another one is aqua. Water is called aqua. Here amine, aqua. According to alphabetical order, amine comes first, aqua comes next. Aqua comes next. That's what the arrangement of the ligands. Remember, while naming the complex, ligands are named first. If only one type of ligands are present, then it is named as such. If there are more than two different types of ligands are present, then you have to follow alphabetical order. Then, how to name the ligands? This is what you have to study thoroughly. How to name the ligands? Ligands are already said. Either they are anionic ligands or they are neutral. If the ligands are neutral, then they have given their common name. Say, for example, carbon monoxide. This is called carbonyl. And nitrogen and NO, nitric oxide, it is called nitrosyl. That's what their common name. Amine, AMMINE for ammonia. And for water, aqua, AQUA, aqua. These are the common names because all these are what? Neutral ligands. For neutral ligands, we have to give their own name, such as amine for ammonia and aqua for water, carbonyl for CO, nitrosyl for NO. And if the ligands are negative, that means anions, commonly every anion, their name ends with E. For example, chloride, E, bromide, E, cyanide, E, nitrite, E, nitrate, E. So almost all the negative ligands they ends with E. That E is replaced by O. That means chloride, E is replaced by O. That's why the name takes what? Chlorido. Similarly, bromide is replaced with E by O is called bromido. So that is the anionic ligands that end E is replaced by O. So this is what the nomenclature of ligands. Remember, neutral ligands are given by their own names such as amine, aqua, nitrosyl, carbonyl, etc. But anionic ligands always their name ends with O. Then, if only one type of ligands are present or two types of ligands present, they doesn't matter. But if only one ligand is present, then you have to use no need of adding any prefix. If there are two same type of ligands are present, then we have to use what? A prefix di before the name of ligand. Suppose three ligands are present, then we have to add what? Tri before the name of ligand. For example, you can see Cl2, it is called dichlorido. In a similar way, if suppose the ligands of the type ethylene diamine, this is called ethane 1,2 diamine, ethylene diamine, triphenyl phosphine, such as di, tri, etc., are used in the name of ligands. Such cases, we have to add a numerical prefix such as bis, tris, tetrakis, etc. Bis means two. Ethylene diamine, there we are using the word is di, there we have to use what? Bis. Bis. In bracket or in parenthesis, we have write the name bis, ethane 1,2 diamine, like that. If suppose there are three are present, then we have to use what? Tris. Say, for example, here you can see one ligand, triphenyl phosphine, triphenyl, pH is 3. There are three pH groups, then phenols are there. Therefore, triphenyl phosphine. Here we are using tri for the ligand name itself. There are two such ligands. Therefore, we have to use what? Bis. Bis triphenyl phosphine for this ligand. And there are two chlorines. Therefore, we have to use the word is dichlorido. We have to use the word is dichlorido, or also you can call it as what? Dichloro. Dichlorido or dichloro. Then, after writing the names of ligands, we have to calculate the oxidation state of the central metal atom. In the last class, we have studied how to calculate the oxidation state of central metal atom. Accordingly, we have to calculate the central oxidation state of the central metal atom. Then it must be written in numerical, Roman numerical. It must be written in what? Roman numerical. Then we have to check whether the complex is cationic complex or anionic complex. It's very important. If suppose counterion is first, then already said counterion is first, then the complex is anion. If complex itself is the first, then complex is cation. We have to check whether the complex is cation or the complex is anion. If complex is cation, then the central metal name ends with the as such, say cobalt, copper, platinum, iron, etc. as such. If suppose the complex is anion, then the name of the central metal atom always ends with 8. Ends with 8. Cobalt, cobaltate, iron, ferrate, copper, cuprate, like that. Always their name ends with 8. It's like modification of the names of the central metal atom. For example, you can observe here one complex anion, cobalt, thiocyanate, you know SCN minus. So SCN minus means what? It is anionic ligand. So already said anionic name ends with what? O. There are four. Since there are four, we have to use the prefix is what? Tetra. We have to use the prefix is tetra. And cyanide, you know, SCN is the negative or anionic ligand or negative ligand, therefore it is called thiocyanate. Tetrathiocyanato. Now you can see charge is negative. Charge is negative. Therefore, Cobalt, it is not cobalt, its name ends with 8. Cobalt, its name ends with 8, therefore it is called cobaltate. Name ends with the 8, cobaltate. If suppose iron is present, then the name ends with what? Ferrite. Ends with the ferrite. We'll got some examples. By looking at the examples, we can come to know the exact how to name the complex. For example, first complex you can go for square bracket, chromium, NH3 3 times, H2O 3 times, bracket close, Cl3. Now, in this complex, you can check. Square bracket is written first, nothing but complex is written first. Indicates what? Entire complex itself is the cation, and the chloride Cl minus is outside the bracket. Therefore, this is counter ion. Counter ion. Complex first, counter ion next. Therefore, complex is cation, counter ion is anion. Complex is anion. Its name. We'll know how to name the compound. We'll go for the rules. Already said, rules are first we have to name the cation. What is the cation here? Cation is complex. So while naming the complex, once again I have said the rules. Ligands first. If only one type of ligands are present, then nothing to worry, you can directly name. If there, since there are two types of ligands, we have to follow what? Alphabetical order. According to the rule, which is comes first, amine, and the one is aqua, which is first AM, AQ, which is first AM. Therefore, amine comes first, aqua next. First, we have identified the ligands, then we have arranged them in alphabetical order. Now we have, since they are not single, there are 3 amine and 3 aqua. Therefore, we have to add the prefix before to the ligands. How to add the prefix here? You can see, since there are 3 amines, therefore we have to say triamine. We have to say what? Triamine. And since there are 3 water molecules, therefore it is called triaqua. Triaqua. Now ligands are done. After naming of the ligands, we have to calculate name what? The central metal atom. Now, to name the central metal atom, already said, we have to check whether the complex is cation or anion. Which is the complex here? Cationic complex. So, the name of the central metal atom ends as such. Chromium. Done. Now, its oxidation state must be written in Roman number. We have calculated the oxidation state. This is neutral, so 0. This is neutral, 0. Therefore, x plus 0 plus 0. This is Cl. What is the charge of Cl? Minus 1 into 3, therefore minus 3. X minus 3 or x is equal to 3, and the oxidation state is 3. Oxidation state is 3. Now, complex is done. At the last, what is left there? Counter ion. Where is the counter ion? Counter ion is outside, and no need of writing the number of counter ions. We have write only one name, that is chloride. So this is for the name of the complex. Name of the complex. Next, we can go for one more complex. Here, cobalt, inside we have, you can see, ethylene diamine. Yesterday I have said it's a what? Didentate ligand. There are 3 didentate ligands are there, and sulfate is there. It's outside. So once again, complex is cation, and sulfate is what? Anion. Sulfate is anion. How to name? Follow the rules. Cation is named first. Which is the cation? Complex is the cation. While naming the complex, what we have to follow? We have to follow ligand first. Nothing to worry, only one type of ligand is present, we have to name it one. What is that ligand? It is ethylene diamine. Ethylene diamine. Ethylene diamine is common name, but while naming the IUPAC name, we have to use what? Ethane, and first position and second position. Therefore, ethane 1, 2 diamine. 1, 2 diamine. Since we are using di here, since we are using what? It's a di here. We have to use what? Once again, one more postulate say, since there are prefixes like di, tri, etc. are used with the ligands, then we have to use the bis, tris, tetrakis, etc. before the name of ligands. So there are three such molecules present. Therefore, we have named them as what? Tris. Hence, we can say tris ethane 1, 2 diamine. Now, ligand is over. After naming the ligand, we have to name what? Central metal atom. While naming the central metal atom, we have to check whether it is a cation or anion. Now, no doubt it is a cation. It is named as such. Therefore, it is cobalt. Now, the oxidation starts. Since it is a neutral ligand, since it is what? Neutral ligand, we have to take it as to be 0. Therefore, x plus 0 is equal to, x is what? There are two couples are there. Therefore, it is 2x. 2x plus 0 is equal to, sulfate you know charge minus 2. Minus 2 into 3 is 6. Therefore, 2x minus 6. Therefore, x is equal to what? 3. Hence, cobalt 3. And already said sulfate is a counterion named as such. We just explain how to use. Sulfate is a counterion. Then, since it takes 3 sulfates to bond with 2 complex cations, the charge on the complex cation must be 3. Further, ethane 1 is a neutral molecule, so the oxidation number of cobalt in the complex must be 3. That's what I've said you how to calculate. And remember that you never have to indicate the number of cations and anions in the same in the name of an ionic compound. So that's the nomenclature of the coordination compound.